Hi everyone, this is Rachel, and today I'm going to do a data visualization review. First of all, what's the data visualization? Actually, it's just mean provide visual representations of data sets, but this representation should help people to carry out some tasks. In another word, it should be meaningful. And a visualization is not a tool that can analyze the data automatically. It just presents the data in an easy read way that can help people to analyze or find something. So a visualization should contain the user, data, and the tasks. If you want to give a visualization, you should do the data abstraction firstly. Why? It is because different attributes means different representations, and the different datasets requires different items. Let's have a look on data and attribute type here. You can find the type of data is not too much. It includes the items, which is an individual entity like a row in table, the attribute, which is some specific property, the link, which is the relationship between items, the grid, which specifies the strategy for sampling continuous data in terms of both geometric and topologic relationships between the cells. And the position, which provides a position in 2-dimension or 3-dimensional space. And we can be more specific in the attributes. An attribute can be categorical, which is used to classify the target to certain category. Ordinal, which is used to order the target. Or quantitative, which can measure some magnitude. Also, there is a special attribute called temporal attribute, which is the attribute linked to the time. Ordinal and quantitative attributes are all ordered, and they have order direction that should be one of sequential, which means one direction from that point, like here, or diverging, which means two opposite direction from certain points, like here, and or cyclic, it's just like a circle. And then it's the dataset type. Table is a very common dataset type, which is built by using row and column. So it includes item and attributes. Network is a map includes kinds of nodes and links. So it includes item, links, and attributes. Field dataset type also contains attribute values associated with the cells. Each cell in a field contains measurements or calculation from a continuous domain. So fields include grids, positions, and attributes. Geometry datasets specify information about the shape of item with spatial positions, and it includes item and positions. Also, there are some other datasets like sets and lists, and actually, they are more like a collection of items. The dataset also has a property called availability, which is presented as static or dynamic, which means if the dataset is available or it's at once. And here is an example for the data abstraction. You can find it's from my homework, and you can see it here. Here is the introduction of the dataset. And this is dataset table. Here I introduce the attributes and their abstraction type. And I also point out the ordering direction and data availability here. And then let's have a look on the data abstraction. Why data abstraction? The reason is a little similar to the data abstraction. Oh, sorry, it's task abstraction. Different problems may have similar task abstraction, and in this case, we can use a similar solution. Also, different items works in different situations, so we should do the task abstraction to select an appropriate items. And how to abstract the task? We mainly use the form action plus target. Action is one of the following parts here and here. It can mainly be divided as analyze, search, and query. The highest level is analyze. The most common use of analyze is for the user to consume information that has already been generated as data stored in a format amenable to computation. The other one is produce some new material from the existing dataset. Both two cases can be divided in more specific verb according to the different target. And the meta level is search, which means search something from the dataset. And it can also be divided by the level of search from search something you know and or search something maybe existing. Finally, it is the lowest level query. According to the different target, user may identify, compare, or summarize the information they found in the visualization. And I think these three verbs are clear enough, right? Sorry. So comparing to the action, the target is more simple. It only includes the trend, which is a high-level characteristic of a pattern in the data. Outlier, which is some data doesn't fit well with that backdrop. And the features, which means any particular structure of interest. And this action and target, with this action and target, we will have many combinations which will cover most task abstraction you will need. Then it is how to do a visualization. The visualization are mainly formed by mark and the channel. Mark is a part of the visualization, and the channels are mainly the property of the marks. You can see that marks are mainly point, line, and area. And the channel includes the position, shape, size, color, tilt, and volume. This mark and the channel means a lot of possibility. This can help you to present the data in kinds of way. And what's the abstraction we see above is that help you to find the best combination to represent your data. After that, the way to build visualization is still long. You can see that we still need the encode, manipulate, fit, reduce the visualization to reduce the data to build a better visualization and make it better and better. It is not a thing that can be described easily in 10 minutes. And I think the better way to learn it is from the actual practice. And then this is an example for task abstraction and how to build it's just a task abstraction. You can see these two are the task, and I point out the target audience here, and the designer and end user is also the target audience. And then I point out the action and target to make it just like a combination of verb and the target. It will be more easier to read here. No, so for the first one, it compares, and the target is feature, and for the second one, it summarized, and the target is the trend. And then here is how I built the visualization by using the encode, manipulate, fit, and the reduce. And I also point out the marks and the channels here. Finally, there is some rules of thumb. First one is no justified 2D or 3D. It means you should consider your map carefully. Most of the time, 3D is not very easy to read because of the cognition of the human. And for the 2D, you still need to build a clear visualization to help the user to read. I-bit memory rule means it means it is very hard for humans to compare the visualization between their memory, but it is easy for them to compare two visualization close to each other. Also, there may be some mistake in the memory. Visualization entry means the sequential of the visualization. You should remember that overview is the first, and then zoom and the filter, and then and finally show the details on the demand. The last one, the function first and the form next rule means you should do the visualization because you have some task instead of you do the visualization because of you have some form. In another word, it means you should focus on the function, the task, the visualization want to present instead of focus on the form. Finally, thanks for watching.